All right, 2024. The roots of the quadratic equation are just plugging the roots into the equation. That is all. So let me try to plug in 2i and see if that works, right? So I'll get 2i squared plus I multiplied by 2i plus 6. 4i squared plus 2i squared plus 6. 4 into minus 1 plus 2 into minus 1 plus 6. Minus 6 plus 6 is 0. So 2i is a answer. So it's either U or U. Let me check and see if 3i is an answer now. Now I know some of our calculators might be able to, not might, will definitely be able to solve this. Alright, so we get in 9i squared plus 3i squared plus 6. So we get minus 9 minus 3, not going to work. Right, so 3i not working. So I just going and double check to see if minus 3i will work. Let me check and see if minus 3i works. So minus 3i squared plus I into minus 3i plus 6. I'll get the 9i squared, but I'm going to get minus 3i squared. So I'll get minus 9 plus 3 plus 6. Minus 6 plus 6. So the answer is C. This is a repeat question. I know that we're going to get x squared minus the sum of the roots is 4x plus the product of the roots is going to be 7. Z bar is the conjugate, so 1 and 3 are the only correct answers here. The modulus of the complex number, we're going to get 36 plus 9 is 45. Root 45 is going to be root 9 by root 5, which is 3 root 5. The expression written in exponential form is, so cosine 30 plus I sine 30. 30 degrees is the same thing as pi on 6. So it's going to be 6e to the pi on 6i. Right, and you could go from here and check it and see, right? E to the pi on 6 is equal to cosine pi on 6 plus I sine pi on 6. And pi on 6 could be my 30 degrees. The gradient of the tangent, this one is going to be 3/4. This is a repeat question. If dy dx is equal to 2xy, then the value of, this is a repeat, boys. A repeat from way back, so let me do it over. When I differentiate, I'm going to get, we have to implicitly differentiate. I'm going to get v by du dx plus u by dv dx, which is 1 by dy dx. And we have dy dx is 2xy. So we have 2y plus 4x squared y. X is 1, y is 2. 2 into 2 plus 4 into 1 squared into 2. 2 to the 4. 4 by 2 is 8. 4 plus 8 is 12. If f of x is e to the x squared ln x, it is a repeat question. We would have to do a couple things for this one. We would have to differentiate and then factorize, and factorize out, I believe, the e to the x squared ln x by bringing the 2 as a power on the ln and factorizing out the x. So the answer for number 8 was A. Number 9 is another repeat question. It's 1/3 tan inverse of the function would be 3x. Yeah, 1/3 tan inverse 3x. This one was the mad question where the point is not on the curve. When we differentiate implicitly, so let me go through and let me do the implicit differentiation, right? The answer for this is negative 39 on 8. Let me go through the implicit differentiation for it. U and V. It's going to be V by du dx, which is going to be 6x squared, plus U by dv dx, which is going to give me 1 dy dx. Minus 3 is equal to, I put in the minus 6 and I differentiate in xy, U and V. V by du dx plus U by dv dx. Let me go ahead and rearrange, right? Minus 6x coming across to give me plus 6x dy dx. So I get dy dx into 6x plus 2x cubed is equal to minus 6y remains there. Move the minus 3 across, becomes plus 3. Move the 6x squared y, it becomes minus 6x squared y. And then I'll divide by 6x plus 2x cubed. So plugging in minus 1 and minus 3, minus 6 into minus 3, plus 3, minus 6 into minus 1 squared into minus 3, all over 6 into minus 1 plus 2 into minus 3 cubed. It's a real dotish question, boy. Right? They're real wicked. This is what you call wickedness. Minus 6 by minus 3 is 18. Plus 3. Minus 6 by 1 is minus 6. And minus 6 by minus 3 is plus 18. Over minus 6 by minus 1 is minus 6. And minus 3 cubed is 8. Minus 3 cubed is minus 8. Minus 8 by 2 is minus 16. So 18 plus 18 plus 3 is 39. And minus 6 minus 16 is 22. So it's supposed to be 39 on top. Did I miss something here, boy? Is 2 into minus 1 cubed. Right? So minus 6 minus 2 is going to give me the minus 8. Right, I put 2y. I plugged in the value of y inside of here, which is minus 3. Alright, so this is a repeat question. The answer for this was pi on 2 minus 1. This is another repeat question, but in a different light. I cannot remember exactly what the answer is for this, but let me go ahead and do it, right? We know that our tan squared is sec squared. Take away 1. So I'll get the integral of sec squared x take away 1. I put in the quarter on the outside here. I'm going to get tan x minus x, and I put the quarter on the outside here. Evaluating between pi and 0. Tan of pi is 0 minus pi. So minus pi on 4 was the answer for this. Right? And now remember. This one is another repeat. I can't remember exactly what the answer was for this. So, again, let's go ahead and do it over. U and dv. So, it's going to be v. So, I'll put v is going to be minus e to the minus x. V by du dx minus the integral of, uv minus the integral of v by du minus 2x e to the minus x minus 2e to the minus x. So I'll get minus 2e to the minus x into x plus 1 plus c. Minus 2e to the minus x into x plus 1 plus c. The answer is A. Oh, good. If z1 is that and z2 is that, then z1, z2 is, well, let me just bring this in exponential form now. 2e to the pi on 4i, that is z1, multiplied by 3e to the pi on 6i. When we multiply them, 3 to the 6e, what is pi on 4 plus pi on 6, which I can see. There's a quarter pi plus a 6, right? So 1/4 plus 1/6 is 5/12, and I'm going to change 5/12 into degrees. So 5/12 pi multiplied by pi on 180. So 5/12 multiplied by 180, that's divided by 180. No. Multiplied by 1 over 180. Oh, it's multiplied by 180 over pi, sorry. 5/112 multiplied by 180 over pi, 75 degrees. Right, so it's going to be 6 6e to the, I'm going to put 75 degrees I, which is equal to cosine 75 plus I sine 75. So the answer is B. The integral of e to the power 3x plus 2, differentiate the power, we get 3. So it's going to be e to the 3x plus 2 over 3 plus c. E to the 3x plus 2 over 3, sorry, plus c. The answer is D. The 20th term is 1 over 20. Which of the following sequences is a convergent sequence? B. The sum to infinity is going to be a over 1 minus r. R is a quarter. 1 minus a quarter, which is 1 over 3/4, which is 4 over 3. The third term in the power series expansion, ln 1 plus x. This was a repeat question. We will use Maclaurin and expand out this. Remember what the expansion for ln of 1 plus x is. Let me just show it again, just to save a little bit of time. So the expansion, not here, the expansion for ln of 1 plus x is x minus x squared on 2 plus x cubed on 3 minus x to the power 4 on 4 and going on. And ln of 1 minus x is just minuses down the road, right? When I take away both by using the law of logs, I'm going to get the third term being 2x to the power 5 on 5. But realistically, the third term, if we count the zeros, is going to be 2x cubed over 3. So you can go back and watch 2021, number 20, to get the answer to be 2x cubed on 3, unless they give me a 2x to the power 5 on 5 here. They didn't, so 2x cubed on 3 is the answer. The sum of the first n terms in a series, the value of the second term is, this was, the sum of the first term is 1 minus a quarter, which is 3/4. The sum of the first two terms is 15 over 16. When I take away both, multiply by 4 over 4, we're going to get 12 over 16, 15 over 16, 3 over 16 is the second term. The series converges to the value. So when we start at 0, we're going to get 5 over 1. Then we're going to get the next term is going to be 5 over 2. Then we're going to get 5 over 4. Now, first term is not going to be a, right? We can factor out the 5. And we're going to have 1 plus a half plus a quarter going down the road. And in this series, the first term is 1. And the common difference is going to be a half. So a over 1 minus r. 1 minus a half is a half. 1 divided by a half is 2, and 5 twos are 10. 22. Which of the following diverges? Ooh, oh God. All right, I'm going to say D. No, I lie. When we tend to infinity, we get infinity on the denominator that is 0. All right, so part A. Let me start with part D, right? So part D will converge. We know that how the minus 1 to the n is the alternating signs, but sine n on n cubed, this converges. All right, and because sine n on n cubed converges, this converges, so therefore this will also converge, regardless that you have the alternating series here, right? Now this here will resemble a geometric progression. If you expand it out, you'll get a GP, so this will converge, and I believe for this geometric progression we could calculate what r is. This one here is the only one that will diverge, because as n tends to infinity, the exponential growth is much faster than the polynomial growth. So the top will go to infinity quicker than the below goes to infinity. So this here, the limit as n tends to infinity for the first one will be infinity. So the answer is going to be E. This is a repeat question. Was it to the power 7? So the coefficient of x to the power 4. Was it x to the power 7, boy? Let me check and see, right? So if we want the coefficient of x to the power 4, then 3x will be raised to the power 4, and the 2y must be raised to the power 3, and we are going to have 7c4 in the beginning. I'm only concerned with the coefficients, right? 3 to the power 4 multiplied by 2 cubed, that is 81 by 8, by, I believe it was by 35. 7c4 was 35. 22,680. Yes, so the answer for this was indeed C. The 10th term of an arithmetic series is 18. So T10. Oh, we did this question already. This is also a repeat question. I believe the answer for this was 390. So T10 was equal to is equal to 18. So 18 is equal to A plus 10 minus 1 is 9 multiplied by D. And it told us the common difference is that 18 take away 27 is minus 9. So S20 is equal to 20 over 2, which is 10, into 2A, which is minus 18, plus n minus 1, which is 20 minus 1, which is 19 by 3, minus 18 plus 19 by 3 is 39. 39 by 10 is 390. Alright, so this here again, 1.67 was the root when you calculate it on your calculator. The coefficient of b squared in the binomial expansion is 40. Then a is equal to, so if the coefficient of b squared is 40, let me get the b squared term. So b squared comes when the second term is raised to the power 2. The first term will be raised to the power 3. And we're going to have 5c3. This is equal to 40b squared. B squared and the b squared cancels. 5c3 is what? 5c3 is 10. So we're going to get a cubed is equal to 10a cubed is equal to 40. A cubed is 4. Something wrong there. Did I make a boo-boo? The coefficient of the term in b squared. Yeah, b squared comes from when b, the power of b is 2. So NCR a to the n minus r b to the, oh, it's supposed to be 5c2. Does this mean I made a mistake with the one before? This is supposed to be 7c3. Because it's NCR a to the n minus r. Yes, this is supposed to be 7c3. Okay, so let me redo number 23 one time for you guys, right? So we're getting 81 multiplied by 8 multiplied by 7c3. We still get 22,680 because 7c4 and 7c3 is the same thing, but just keep that in mind, right? We still have the answer correct. Over here, 5c2, we're getting a wrong answer. It's supposed to be 5c2, which is also 10. Very coincidental. I mean, not really coincidental. It's purely mathematical. But I can't shake why. A to the n minus r, b to the r. That's b squared up there, right? Let me check back and see if it is b squared. I know it's a repeat question. Alright, so can confirm this is a b cubed. So the question will read over. So the coefficient of b cubed, we're going to have b cubed here. We're going to have a squared here. Is 40b cubed. And we're going to have here 5c n minus r 5c 3. So 5c3 and 5c2 is 10. A squared is going to give me the 40. A is going to be root 4, sorry, which is going to give me 2. Alright, this one is a repeat. Rearrange. I know we will get a plus 25 in the end, so it's either here or here. Both denominators are the same. If I'm not mistaken, D was the answer for this one, but I'm going to still do it over. Is x take away the function, which is x to the 5 take away x cubed take away 25, divided by the derivative of the function, which is 5x to the power 4 minus 3x squared. Cross multiply 5x to the power 4 plus minus 3x squared minus x to the power of, so the 5 here and cube here. So 5x to the power 5 minus x to the power 5 is 4x to the power 5. D is the answer for sure. Alright, the value of this is a over 1 minus r c. The value of this is, we're going from 1 to infinity. A is 1. R would have been a quarter. The answer for this is 8 over 3. Alright, so the interval bisection twice. The answer for this was between a quarter and a half. Ooh, new question. Given that 12CR is equal to 12C 2R minus 3, the value of R is, well, I know 12C8 is equal to 12C4. And that really helped me. So we know that how NCR is n factorial over n minus r factorial by r factorial. So 12CR is 12 factorial over 12 minus r factorial, and it's equal to, what is, it could be 12 factorial over 12 minus 2r minus 3 factorial, 2r minus 3 factorial. Alright, so the 12 factorial and the 12 factorial could cancel out. Let me fix up the middle now. So we get 1 over 12. Why doing all this for? Let me just test it and see. Oh, Jesus, Lord, Father. The working there to do, though. Let me test the numbers. 12C2. 66. But let me take them away now. 12C2 take away 12C 2 to the 4. 4 minus 3 is 1. Nah. 12c5 take away 5 2s are 10, 10 take away 3 is 7. Yeah, 5 is the answer. Cool. What's the probability that 5 tosses of a fair die contain exactly 3 5s will occur? 5 tosses of a fair die. So we're going to get a 5 on the first one go be 5 tosses of a fair die. What? That in 5 tosses of a fair die, exactly 3 5s will occur. So out of the 5 tosses, 3 5s will occur, right? So we're going to get 1/6 could be a 5, 1/6 could be the next 5, 1/6 could be the next 5. So exactly 3 5s, right? That's the probability that the 3 5s going to occur. All right. Then the probability that the 5 doesn't occur, I want to say I had to multiply it by 5 6 by 5 6 to give us the 5 tosses. Let me check and see what we get for this here. This is going to be 6 to the power of 1 2 3 4 5. That's going to be 77 76. Yep. And 25 on top. Alright, so I'll make a tack back to come back and tackle this question, right? This piece here, solid, right? The number of ways that we can get the 3 5s to occur is like this. But this could occur a number of ways. The way I have it listed right now is if I do get a 5, if I get a 5, get a 5, get a 5, then I do get a 5, do get a 5. But it do have to occur in this order. The number of ways in which this could occur is going to be 10 ways. So if this is the probability of one of the ways, the probability of 10 of the ways is 250 over 77 76. And 250 divided by 77 76 is 125 over 38 88. Alright, so let's just cross our fingers. If a question like number 32 comes, it comes exactly like this, or this exact same question comes as a repeat. Alright, number 33 again. Ooh, the change of the answers we have here, I think. But the correct answer is 3/10 for this one here. Product of the two numbers is prime. So the answer for this is 3/10. But I think that's how the answer that they wanted was 3 over 25, right? There's a repeat. 34 is a repeat. 2 boys and 3 girls. Right, 35. The cofactor of the element 3. So here and here, that's going to be positive 1405. 1405, the answer is C. Alright, so all 3 awards there's a repeat question. I can't remember what the answer is, but I remember how to get it. We have 35, so the probability that the first boy wins the award multiplied by the second boy wins the award multiplied by the third boy wins the award. Let me check the answer. 20 divided by 35 multiplied 20 by 19 by 18 divided by 35 by 34 by 33. 0.174. The answer is C. 25 on 90. Female drinks drink B. 25 on 90. Alright, this one here, we had to draw the probability tree diagram. And I'll just go back to the probability tree diagram, because it was an extensive probability tree diagram. I'm sure it was in this paper, wasn't it? Where is my tree? Oh, it was here before this? Okay. Alright, look at the tree diagram here. First branch is 1 child, second branch is 2 children, third branch is our 3 children. For this one here, with 3 children, we have 2 girls and 1 boy. 0.432 was the answer. So you can revisit the previous 2 years. This is 2022, number 38, to get 0.432 as the answer. This is a repeat, not parallel. Have a unique solution, 2 and 3. Number 40 is a repeat as well, 18. New question. A is A, B, C, D, E, F, G, H, I. B is A, B, C, D, E, F, G, H, I with K in the middle. If the determinant of matrix A is 20, what is the determinant of matrix B? So for matrix B, we can factorize out the K, but we cannot put the K outside. So our row will be multiplied by K. And if I remember correctly, then the matrix, the determinant of the matrix will also be multiplied by K. So when you factor out the K from here, we must multiply this by K. So the answer is going to be 20K. Given that the determinant of M is 62, the value of X is, yes, this was a repeat question. We would have gotten minus X plus 69 is 62. And minus X was minus 7. And X was 7. And the singular matrix will occur when the determinant is 69. When X has a value of 69, sorry. And that's it for 2020. Never mind. This is a repeat question. B is the answer. And 45 is also a repeat question. Make sure. Yep. A is the answer. And that's it for 2024.